Let's talk about measures of central tendency. These are the mean, median, and mode. The purpose of these measures of central tendency is to get a sense of the overall distribution of a data set. And there are a couple of ways that we can do that. So what we've got here on the screen is an actual data set of the price of houses. You can see a bunch of attributes of the data. So you can see how big the lot is, if the street is paved, whether or not it's on an alley, if it's a two-story house or one-story house. First thing I'm going to do is I'm going to select everything and I'm going to format it as a table. This doesn't change the data, but it does make it a little bit easier to read. So that was just using the format as a table here. There are a lot of columns, so let's come all the way over to the end. The final column is sale price. So if we click on this one, at the very bottom, just by clicking on the top, it tells us a couple of nice pieces of information. We get the average, so the average is the same as the mean. The average sale price is $180,991.20. And the count, that's how many of these are in the data set. We also get the sum. For some data this is useful, the data that we have here, that is not a useful number. There's no value in knowing that the 12 or 1400 properties all add up to some big number. What we care about is how these are all distributed. Um, Excel has a number of nice features that it can calculate things for us. So let's find the mean, the median, and the mode. And we'll just say this is equal to average. And I'm going to hit Shift Command to select everything in that column. Enter. And it has done that. It automatically populated this because it's something that does it as, since it's formatted as a table. Now let's calculate the median. Do the same thing. Clicked on here, Control Shift down, selects all the values, and stop automatically doing that. And mode. This is the number that appears most often. All right, so the mean is exactly what we had seen before. We looked at this. It's that number. It's the exact same. Median, that is the number that appears exactly in the center of the data set. The value of a median is that it is not affected by outliers, where a mean is affected by having extreme values on either side. And the mode is the number that appears most often. That is not a very useful number in any kind of real analysis. So it's often included that you have mean, median, and mode, but it's not something that is useful. When we have a set of data like this, univariate data, so one variable data, one of the things we might want to look at as well is a histogram of that data to look at the spread. So we can select this, go to Insert. We have our different options for chart types. This one here is called Statistical. And if you click on the Statistical, it gives us a histogram. So this is the frequency of these values. There are 11 values between 35,000 and 60,000. We can see there's one property, two properties way down here that are very expensive. Overall, we can see the curve. We would say this has a skew to it because it's shifted here. It's positively skewed because the numbers extend here in a positive direction. One of the downsides of the way that Excel does this is that it puts things in bins arbitrarily. But we can change that by clicking on the data set. I'm going to right click and go to Format Data Series. And so I can do things like change the color. If I want to make the color, instead of that blue color, we can make it orange. Go Bearcats. And here I can change the bends. So rather than auto, let's say I want a number of bends, so just make the bends, and I only want to have 10 bends. So we can see that affects the way that this looks. It's still clearly positively skewed. If we did 100 bends, you see more spikiness in the data because you have smaller numbers. Again, the downside here is that the break-offs of these are not meaningful. So if you think about this for grades, grades have a very specific range. So like a 60 to a 70 would be a D, 70 to 80 is C, 80 to 90 is B, and 90 to 100 is A. Excel would probably break it down and not use those specific numbers. So you can go in here and set it, see, by bin width, and you can say you want your width to be something like 10,000, so it will do it in $10,000 increments, which are easier to read and interpret. So we can see the skew here. So our mean is here. We can see a little bit about which numbers appear more often than others as in the bins. So those are all measures of central tendency. This is a histogram for that. Another tool we can use to see this spread of the data is we go to insert. It's called a box and whisker plot. And again, go to statistical. It's here, box and whisker. And this is showing the same information that we just saw, except it's kind of oriented vertically. The little dark line in the middle is our mean. The X should be our median. We can see the range in quartiles, so bottom 25. This is the middle or inner quartile range, and then we see these outliers up here. A box and whisker plot can sometimes be a really useful way, especially when you're comparing multiple groups of data, to see them all at the same time, whereas a histogram can get busy if you put one histogram on top of another. Right, so that is a box and whisker plot and a histogram. Right. One last thing to show on this, you have this package called XLStat. So if you open it up, then you can come over to visualizing your data, histograms. And you can do the same thing here. I'm going to select this column of data. It's continuous. It's important to click that yes, there's a label here. And I can tell it where I want it to output. It's going to be in this group. It's all fine. I'll hit OK. And I did something wrong. Let's go histogram. Oh, it's because I don't have any subsamples. So there we go. There we go. I've got this data. We know it's 1,460 rows of data. And it's going to turn for a little bit. And here we go. It's a very basic looking histogram. It did much larger bends than Excel did. It also did nice things for us, like it's already calculated the number of observations, minimum, maximum, and the mean. So that was something that we calculated on our own, and the standard deviation is given here to us. We can see relative frequency that fill out this chart. There is a way, if we go back in our histogram, to control some of the other options. So it did 4 bins because that's what's checked here. So if we wanted to say instead, let's do, let's do 30 bins. We can see, yep, do the same thing. And now we've got 30 bins, which is the same thing we saw in Excel, but just using this Excel stat package, which is an add-on to Excel. It gives you some additional information. Makes this actually really quite easy.